Welcome to this special episode of Frequency Matters, the RF Microwave Update series. I'm Pat Hindle, and today I'm talking with Paulo Marquez. He's the founder of All Smart and professor of wireless communications. Welcome, Paulo.
Welcome, Pat. It was a pleasure to be here. Thank you for the invite.
So I saw that your team has developed open source systems for researchers doing wireless systems, new modulations and new schemes to develop new systems. Can you tell us about open source systems for 5G and 6G research? What are the advantages to this type of setup and, what are its capabilities?
Sure. So, practical experimentation with cellular networks has been historically reserved for big network vendors and telecommunication operators. This is mainly because of the price of the equipment and constraints related with licensing. But in recent years, Open Air Interface is an international open source project, emerged as the leading open source initiative to provide a reference implementation for the 5G 3GPP stack. So thanks to Open Air Interface and also having software-defined radios, like the ones provided by Emerson NI, the USRPs, today it's possible for a small research team or a university to build an open source 5G test network in their lab, play with 3GPP protocol stack, and do real experimentation with mobile phones. So in this context, our company, Smart, we are associate members of the Open Interface Software Alliance and the big contributors to the open source code. We have developed a product that is the OAI box that works as an abstraction layer to facilitate the use of the Open Air Interface stack. So using a web-based dashboard, it's possible to monitor and control the open source 5G test network. So researchers can accelerate experimentation of the 5G stack and test new research ideas. So you mentioned about the future and 6G. So we see, of course, 6G is going to be available around 2030, but it's an evolution of 5G. So it's very important to have a 5G stack to start building on top and test new research ideas. And we believe that open source solutions are very important in this pre-standardization phase of 6G because of the complexity of the 5G networks and the future 6G networks. Simulation is not enough. You need to have real test beds to extract data, for instance, to test the artificial intelligence algorithms that are now being proposed for 6G.
And so how does this democratize the system development work, and who are the likely users? Also, what companies are involved in support of this type of effort?
Yes, today the commercial 5G networks are typical black boxes. So it's not possible to change a lot of configurations or even the protocol stack. So it's why Open Air Interface is important as an open source solution to democratize wireless innovation. And this has been recognized by big names of the industry like Qualcomm, AMD, Emerson, NVIDIA, Orange. They are supporting this open interface initiative that is led by a research center in the south of France, Eurecom. So the users of the open interface and the OAI box are typically universities, research centers that are looking for an open source platform to test new research ideas. So it's very aligned with this idea of democratizing wireless innovation. You don't need to be part of the big vendors to test a new idea in the 3GPP stack end to end. So it is actually open innovation, and I think it's very important for the future of wireless communication.
Well, it sounds like you have some great support there. So can you tell us about the system configuration and its components? How is it put together?
Yeah, in our OAI box product line, so we start having a monolithic solution where the GNOP, the 5G base station, and the core network are integrated in the single computer, in the single platform, is what we call the monolithic solution. But then the system has evolved to meet the requirements of our customers. And today the OAI box supports Open RAN architecture, with a disaggregated G-Node B. So you have the central unit, the distributed unit, the radio unit with an open fronthaul. And more recently, in partnership with Tumitech and Emerson NI, we have created a WireBox millimeter wave that is a test network for 5G millimeter waves or frequency range to around the 28 gigahertz band. In terms of configuration, so the open source protocol stack and the WireBox allows a lot of configurations. So it's possible to run speed tests to measure in real time signal power levels. And this data can be then exploited, for instance, for fine-tuning artificial intelligence algorithms that are one of the key words, let's say, for the evolution towards 6G.
Well, it sounds like you have a great setup there. And I know you have a great demo, so maybe you can show us a demo of the system and talk about your augmented reality app, which is really cool that you've developed.
Yeah, thank you. The WireBox solution is also used not just for research, but for teaching to bring the 3GPP protocol stack into the schools. Some of our customers are professors at universities. They use the solution for research, but also for education. And in partnership with these professors, we have developed the 5G lab manual for hands-on education and training. But we also realize that teaching wireless communications suffers from this issue that the radio waves are invisible for us, for the human being. You cannot see the radio waves. So we have created this augmented reality application for the visualization of the millimeter wave beams. It's an augmented reality application that interacts with the Tumitech phase array through an API to control the beam and, for instance, to avoid obstacles. So with this application, we show the concept of reconfigurable antennas, beam tracking, and how reflective surfaces can extend coverage. So we published this video on LinkedIn and social media, and we are quite surprised about the positive impact that this application has done and the feedback we got from the wireless community. So this motivates us to develop new augmented reality features to visualize 5G radio signals. And I think this is important for the aspect of teaching and education of the workforce that is going to work with the infrastructure of our digital society.
It's a great visualization of what happens. So great that you did that. So thanks, Paulo, for talking with me today about open source communication systems and their role in the research and development of new systems. To our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.